Let us continue atomic structure numericals. Yesterday we took one example. We took one problem at last for that maximum energy of photon. Maximum energy of photon answer is maximum energy photon answer is 13.5 electron volt. Maximum energy photon answer is 13.5 electron volt. Minimum energy photon is 0.7 electron volt. Okay, let us go to next sum. Next sum we are taking an electron beam can undergo diffraction by crystals through what potential? Through what potential? A beam of electrons be accelerated. On that, the beam of electrons accelerated so that its wavelength becomes equal to 1.54 angstrom. Sorry. Now, here the question is what in the sense of diffraction. Your question is diffraction. What diffraction in the sense? Electron diffraction. Sorry. Now we will consider electron beam. We'll consider electron beam. Sorry. Now it is the electron beam. This is what means electron beam. Beam of electrons. The beam of electrons should go in a particular direction. It is directed towards particular direction for which here negative plate is placed and here positive plate is placed. Due to electrical potential, the electron beam is directed like this. Then it is allowed to bombard on crystals. For which crystal we want to diffraction experiment, that over that crystal this electron beam is allowed to bombard. Then we will get a diffraction pattern, we will get it. Set. Now in this electron beam, because of this external electric field, this electron beam is directed towards particular direction. That means the electron beam is directed towards particular direction by electric field, in the sense the kinetic energy of electron beam is nothing but given by electron beam, electric potential. Okay, so kinetic energy of electron beam is nothing but energy provided by external electric field. Now here electric potential we are supplying. Because of electric potential, electron beam is directed in particular direction. Therefore, kinetic energy of electron beam is nothing but energy provided by the electric field. So, energy provided by the electric field is equal to charge of electron into potential difference. So, kinetic energy of electron beam is equal to charge of electron into potential difference. So, kinetic energy of electron beam, we will take it as half mv square. Charge of electron is E. Potential difference, we will take it as a capital V. This is small v, will take this small v. So here capital V is nothing but potential difference. Sir, okay. So half mv square is equal to EV. Now here we'll see. What is the question they are asking? See, through what potential? Through what potential? Potential they are asking. Through what potential a beam of electrons be accelerated so that its wavelength is 1.54 angstrom. So this is the wavelength for what? This beam of electrons. For electron beam, wavelength is given. Potential is asked. Set. So now we have to find this potential. We have to find this potential. This potential value we have to find it. What is given in the sense lambda is given. Lambda is equal to what is the formula as per de Broglie? H by mv. Now we have to substitute this v from here. So this v square is equal to ev into 2 by m. So that v is equal to square root of 2ev by m. This v is called velocity. That velocity we will substitute here. Therefore lambda is equal to h by m into square root of this 2ev by this m. Okay. Now we will write lambda is equal to h by 2mev. Okay, like this we have written. Now we will substitute the values and we will get this potential. This potential we have to get it. This v is called potential. Potential they are asking. So now we will substitute lambda. Lambda is equal to 1.54 angstrom. That we will convert into meter in SI system. So lambda is equal to 1.54 into 10 to the power of minus 10 meter. So lambda value we substituted. Then h value we will substitute. H is 6.625 into 10 to the power of minus 34 joule second. Then divided by this square root of 2 into m is called mass of electron. Mass of electron is 9.1 into 10 to the power minus 31 kilogram. E is called charge of electron. Charge of electron is 1.602 into 10 to the power of minus 19 coulomb into V. V is called potential difference. So on simplifying this, we will get we can get V, that V is equal to, we can get V. So V is equal to how much in the sense 63.3 volt. 63.3 volt we are getting. Set. We'll go for next question. What is the maximum precision? What is the maximum precision? What is the maximum precision with which the momentum of an electron, the momentum of an electron can be known. The momentum of an electron can be known if the uncertainty in the position, if the uncertainty in the position, uncertainty in the position of electron is plus or minus 0.001 angstrom. Will be any problem in describing, will be any problem in describing, will be any problem in describing the momentum, if it has a value of, if it has a value of h by 2 pi a naught, h by 2 pi a naught, where a naught is Bohr's radius, where a naught is Bohr's radius, where a naught is Bohr's radius of first orbit, that is 0.529 angstrom, 0.529 angstrom. Sir, now the question is what is the maximum precision with which the momentum of an electron can be known? Sir, that means they are asking us to find momentum with the maximum precision. So maximum precision of momentum of electron we have to find it. Sir, that means maximum precision of momentum. Maximum precision of momentum of electron. This meaning is, what is the meaning of this means? Minimum uncertainty of momentum of electron. That is the meaning. Maximum precision means what? Maximum accuracy. Maximum accuracy means inaccuracy should be minimum. So maximum precision of momentum of electron means minimum uncertainty of momentum of electron. Set. Next, if the uncertainty in the position of electron is 0.001 angstrom, okay, uncertainty in position, therefore delta x is given. Delta x is equal to what they said means plus or minus 0.001 angstrom. Uncertainty in the position of electron is plus or minus 0.0011 angstrom. Therefore, what is the maximum uncertainty? What is the maximum uncertainty in position of electron? What is the maximum uncertainty in position of electron? Okay. So maximum uncertainty in position of electron is how much in the sense 0.001 angstrom we can say. Maximum uncertainty in position of electron is 0.001 angstrom we can say. Because uncertainty in position is plus or minus 0.001 angstrom. Therefore, maximum uncertainty can be 0.001 angstrom. More than that, it is not possible. Less than this possible. Less than this uncertainty possible. More than this uncertainty is not possible as per the given value. Set. Now, we will find a minimum uncertainty in position. So, uncertainty in the sense Eisenberg principle. So, Eisenberg principle says delta x into delta p is greater than or equal to h by 4 pi. Set. Now, this is a uncertainty in position is maximum. This is maximum in the sense it is minimum. Okay, the product is what means constant. It is maximum and it is minimum means the product is constant. Then we have to take what in the sense equal to we have to take. Therefore, delta x into delta p is equal to h by 4 pi. Delta x into delta p is equal to h by 4 pi we can say. Because it is maximum, therefore minimum. Product is a constant, therefore equal to h by 4 pi we can say. Now we will substitute delta x. Delta x is how much in the sense 0.001 angstrom. So delta x is 0.001 angstrom. Angstrom we are converting into meter. Into delta p. Delta p is called uncertainty in momentum, that is minimum value it is. It is equal to h value Planck's constant. Planck's constant is this much joule second by this 4 pi is 3.14. So by simplifying this we can get uncertainty in momentum, we can get it. Uncertainty in momentum. So delta p is equal to 5.27 into 10 to the power of minus 22. What is the unit? Momentum means mass into velocity. Momentum means mass into velocity. Therefore, we can say here Newton second. We can say Newton second. Uncertainty in momentum. This is minimum uncertainty in momentum. We got it. Minimum uncertainty in momentum means maximum precision. So we got maximum precision of momentum of electron. We got it. So next question we'll see. Will be any problem in describing the momentum if it has a value of h by 2 pi a naught. So momentum is how much they are saying means h by 2 pi a naught. They are saying a naught is Bohr's radius, that is 0.529 angstrom. That is given. Sir. Now we will take this formula and using this formula we will find momentum. We will find it. Okay. So as per the question, we will go for momentum. We will go for momentum. Momentum is equal to what is the formula means h by 2 pi a naught. So we will substitute h. H is 6.625 into 10 power minus 34 joule second. Then this 2 pi value will substitute 3.14. A naught is given. A naught is how much means 0.529 angstrom. 0.529 into 10 to the power of minus 10 meter. So we substituted everything in SI system. We are calculating the momentum. The momentum comes as 2 into 10 to the power of minus 24 Newton second. So now it is a momentum value, and we got even a minimum uncertainty in momentum also. Both values we will compare it. Both values we will compare it. Now we will see this value, momentum is this much, uncertainty in momentum is this much, uncertainty in momentum is this much, momentum is this much, momentum is 10 power minus 24, uncertainty is 10 power minus 22. So which is higher value? Which is higher value? See, it is 10 power minus 2. Uncertainty in momentum is 10 power minus 2. Momentum is how much? Means 10 power minus 24. So that which is higher value in the sense uncertainty in momentum is higher. Therefore, delta P is greater than this momentum. How many times greater? 263.5 times greater. Delta P is called minimum uncertainty in momentum is 263.5 times greater than momentum. Uncertainty is this many times greater than this value means can it be accepted? Can we say that it is a momentum? Can we say this is a momentum as per which rule? As per Bohr's. As per Bohr's concept. As per Bohr's concept. Uncertainty is to this many times greater than this in the sense how can we say this is a momentum of electron in a circular orbit? That's why Niels Bohr model is not considered in the quantum mechanics. Niels Bohr model is not considered in quantum mechanics because Niels Bohr says circular path, particular circular path. It says particular circular path. That is not possible. Sorry. We'll go to next question. On the basis of Eisenberg's uncertainty principle, Eisenberg's uncertainty principle, Eisenberg's uncertainty principle show that the electron cannot exist. The electron cannot exist within the nucleus. Cannot exist within the nucleus. So using Eisenberg uncertainty principle, what we have to say in the sense electron cannot exist in the nucleus, we have to say. Now we will consider atomic radius. Atomic radius is roughly 10 to the power of minus 10 meter. Nucleus radius is roughly 10 power minus 15 meter. Now we will find uncertainty in position. Uncertainty in position of electron. Uncertainty in position of electron in nucleus. Okay, uncertainty in position of electron in nucleus. That is how much in the sense nucleus radius is 10 power minus 15 meter. Nucleus radius is 10 power minus 15 meter. Therefore, uncertainty in position of electron in the nucleus cannot be greater than 10 power minus 15 meter. Therefore, uncertainty in position of electron in the nucleus cannot be greater than 10 power minus 15 meter. Therefore, maximum uncertainty in position of electron is 10 power minus 15 meter. Okay. Now we will take a Eisenberg uncertainty principle, that is delta x into m delta v is equal to h by 4 pi. This equal to means this is a product is minimum. Product is minimum. If you say greater, product goes higher value. If you say equal, here equal, if you say this product is minimum value. Okay. Now we will substitute delta x. Delta x is 10 power minus 15 meter. M is called mass of electron. Mass of electron is 9.1 into 10 power minus 31 kilogram. H is Planck's constant. Planck's constant value is this much joule second by 4 pi. Pi is 3.14. From this, what we can find in the sense delta V we can find. Delta V we are finding. Delta V is equal to 5.79 into 10 to the power of 12. 10 to the power of 12 here 10 to the power of 10 meter per second. So delta V, we got it. Sir, here delta x value we have substituted. Delta x is maximum, we said. Therefore delta V is minimum. Okay, sir. So we got delta V. Delta V is called a minimum uncertainty. Minimum uncertainty in velocity. Minimum uncertainty in velocity of electron in the nucleus. Minimum uncertainty in the velocity of electron in the nucleus is equal to how much we got in the sense 5.79 into 10 to the power of 12, 10 to the power of 10 meter per second. Now we will see velocity of light in vacuum. Velocity of light in a vacuum. Velocity of light in vacuum, we will find it. Velocity of light in vacuum is 3 into 10 to the power of 3 into 10 to the power of 8 meter per second. So velocity of light, we got it. Now we will compare these two values, minimum uncertainty value and this velocity of light in vacuum. We will compare how it is there, we will see. So how the value is there means this value is greater than this value roughly 100 times. 100 times. So can electron revolve more than that of velocity of light in vacuum? Is it possible? It is not possible. It is not possible in the sense electron cannot exist in the nucleus. So we can say electron cannot exist in nucleus. Electron cannot exist in nucleus, we can say. Let us go to next problem. A stationary unipositive helium ion. A stationary unipositive helium ion emitted a photon corresponding. Emitted a photon corresponding to the first line. Corresponding to the first line. To the first line. H alpha of Lyman series. H alpha of Lyman series. That photon liberated. That photon liberated a photoelectron. A photoelectron from a stationary hydrogen atom. From a stationary hydrogen atom in the ground state. What is the velocity of photoelectron? What is the velocity of photoelectron? What is the velocity of photoelectron? Sir, velocity of photoelectron, we have to find it. First we will see here unipositive helium ion given. It is giving a first line in Lyman series. So what is the corresponding energy? That we will find it. Corresponding energy, we will find it. So energy is equal to Hc, Rydberg's constant, Z square into 1 by n1 square minus 1 by n2 square. Now Hc into Rydberg's constant. Hc into Rydberg's constant is 13.6 electron volt. Hc into Rydberg's constant is 13.6 electron volt, we can say. In terms of joule, in the sense 2.18 into 10 to the power of minus 18 joule. Set Z square, unipositive helium ion. Helium ion means Z is 2, therefore 2 square 1 by. Here Lyman series means N1 is equal to lower level is 1 and N2 higher level. First line, H alpha line means N1 plus 1, therefore 2. Okay, N2 we substituted. So we are getting energy, we are calculating. Energy is how much in the sense 6.54 into 10 to the power of minus 18 joule. 6.54 into 10 power minus 18 joule. Okay. So photon, so energy photon is allowed to fall on hydrogen atom in the ground state. Therefore, from the hydrogen atom, electron is coming out. That coming out electron is having velocity. So now we'll take hydrogen atom in the ground state. Hydrogen atom in the ground state. This photon is falling on this. Therefore, what happens means from this electron will be ejected out. Electron comes out. Electron comes out. So hydrogen atom in ground state will take hydrogen atom in ground state. So nucleus. So first level electron. This first level electron is having how much energy means energy of first level electron is minus 2.18 into 10 power minus 18 joule. We are giving photon to this. The photon is having how much energy? We are giving photon to this one. The photon is having how much energy means 6.54 into 10 to the power of minus 18 joule. Photon is having this much energy. This electron energy is this much. So this photon is falling on this electron. So in this, this much energy is utilized for breaking the attraction between nucleus and electron. So electron comes out. So electron came out. The came out electron has kinetic energy. Okay, this electron is having kinetic energy. Kinetic energy of this electron is equal to this initial energy. Kinetic energy of this electron is equal to initial energy minus energy utilized for breaking the attraction between nucleus and the electron, that is 2.18 into 10 power minus 18 joule. So this will give kinetic energy of electron. Okay, so we are getting kinetic energy of electron from this one, that is 4.361 into 10 to the power of minus 18 joule. Okay, kinetic energy of electron, we got it. Now what they are asking means velocity of photoelectron. Velocity of photoelectron. So kinetic energy is half mv square. Half mv square is equal to 4.361 into 10 power minus 18 joule. Now we will substitute the values 1 by 2. M is called the mass of electron. Mass of electron is 9.1 in 10 power minus 31 kilogram into V square is equal to 4.361 into 10 power minus 18 joule. So by simplifying this, we are getting velocity. Velocity is equal to 3.09 into 10 to the power of 1, 10 to the power of 10 to the power of 6, 10 to the power of 6 meter per second. It is a velocity of photoelectron. We'll go to the next sum. In the next sum is what is that means matching. So first one is Vn by Kn. Vn by Kn is equal to question mark. Vn by Kn is equal to question mark. Next one is radius of nth orbit is directly proportional to energy of nth orbit power x. X is equal to question mark. Next, third option, third one, angular momentum in lowest orbital. Angular momentum in lowest orbital. Angular momentum in lowest orbital. Fourth one, 1 by radius of nth orbit, radius power n. That means radius of nth orbit we can say is directly proportional to z power y. Z is called atomic number. Y is equal to question mark. So for this, what are given in the sense 0, then -1, then -2, then 1. We have to match these. We have to match this. Set. Here, what is Vn? Vn is called potential energy. Here, Vn is called what means potential energy. Kn is called what means kinetic energy. Kn is called kinetic energy. Rn is called radius of nth orbit. This Rn also called radius of nth orbit. En is called energy of nth orbit. So this we have to find it. So first potential energy by kinetic energy, that we will see. Now we will take energy of electron. Potential energy by kinetic energy, we have to find it. So energy of electron, what is the formula in the sense? First we will take a potential energy. Potential energy is equal to Coulombic force into displacement. Coulombic force is equal to charge of one body. Charge of one body means a charge of nucleus into charge of another body, that is electron, by distance between them square into some constant k, into displacement is r. Therefore, potential energy is equal to minus k z e square by r. This is a potential energy. Kinetic energy is equal to what in the sense of mv square. Of mv square is the kinetic energy. So, kinetic energy is equal to half mv square. In the place of mv square, we are substituting how much in the sense k z e square by r we are substituting. Then energy of electron is sum of these two, therefore minus 1 by 2 k z e square by r. So energy of electron is minus 1 by 2 k z e square by r. Kinetic energy is 1 by 2 k z e square by r. Potential energy is equal to minus k z e square by r. Now they are asking a potential energy by kinetic energy. So potential energy is how much in the sense minus k z e square by r. Kinetic energy how much in the sense 1 by 2 k z e square by r. Okay, so what is the ratio? You know it. So we can say the ratio is potential energy by kinetic energy is so and so. Okay. Now radius of nth orbit is directly proportional to energy of nth orbit power x. X is equal to what they are asking. X is equal to, we have to find it. So radius of nth orbit and energy of nth orbit they are same. Okay. Radius of nth orbit formula is what in the sense? Formula is 4 pi square m z k e square by here radius of nth orbit, it is not radius of nth orbit. Radius of nth orbit is n square h square by 4 pi square m z k e square. It is radius of nth orbit. Energy of nth orbit is minus 2 pi square m z square k square e power 4 by n square h square. So now we will rewrite radius of nth orbit is equal to what means h square by 4 pi square m k e square, okay, into n square by z. N square by z we have written. This is what means radius of nth orbit we have written. So n square also we will write here itself, we will write n square we will write here, z alone we will write this side. Now energy of nth orbit is equal to what in the sense of minus 2 pi square m k square e power 4 by n square h square, z square is there like this. This is energy of nth orbit. Okay, so you see this value and this value, you see how it is there here, you see that. So in order to substitute this one, what we have to do, that you see it. Okay, so if you want to substitute this here, so what we have to do, so we will reverse this. First we will reverse this. So what we will get, we will see. So 1 by radius of nth orbit is equal to what we can say in the sense 4 pi square m k e square m k e square by what we can say in the sense n square h square into z. So we want to bring into this case, we want to bring to this place. So what we have to do, okay, in order to bring to like this, so what we have to do means 1 by 2 into 2, like this we will take it, 1 by 2 into 2, therefore it will become 2 pi square. Okay, then the k square is there, therefore here 1k, here 1k, e power 4 is there, therefore here e power e square, e square. Okay, so now what will happen in the sense this is becoming how much in the now we can say that this in this place we will substitute this, therefore 1 by radius of nth orbit is equal to this minus, we will write this place we are substituting now this one. So energy of nth orbit equal to minus 2 pi square we want. So if you want to make it as 2, if you want to make it as 2, outside we will write 2. Okay, then this we want to make it as a k square, so outside we will write 1k. This we want to make it as e power 4, therefore outside e square we will write it. Okay, next so we will write here z is there, here z is there, but here z square is there. Therefore what we have to do in the sense, denominator 1 is z we will write, denominator 1 is z we will write. Okay, denominator 1 is z. Now we will write this en, this en we will write it, en in the, okay, we have written en, we have written. Okay, so en we have written, en not, then we are writing here in the sense Rn only we have to write, no, so Rn we have to write, so radius of nth orbit we have written. So here what is there means z is there. Now 2 is constant, k is constant, e is constant, therefore this and all we will take it as a constant, so we will take proportionality, so this z we will take. Okay, this z alone we will take. Z also a constant for a particular species, therefore these are constant, so radius of nth orbit is directly proportional to energy of nth orbit, minus is there, so radius of nth orbit is directly proportional to energy of nth orbit, and minus sign is there. Due to minus sign we will write -1 here. Therefore this x is equal to what in the sense -1. In this place x we said x is equal to how much in the sense -1 we can say. So therefore x is equal to how much in the sense -1. Okay, so we got x is equal to -1. Then angular momentum in lowest orbital means s orbital. S orbital in the sense azimuthal quantum number is 0, therefore angular momentum is 0. Next 1 by radius of nth orbit is directly proportional to z power y, that we will see. Now radius of nth orbit is equal to 0.529 n square by z angstrom. Therefore radius of nth orbit and z are inversely proportional, therefore z power how much means 1, therefore y is equal to how much means 1. Okay, so we'll go to next question. With what velocity should an alpha particle travel towards the nucleus of a copper atom, so as to arrive at a distance 10 power minus 13 meter, from the nucleus of the copper atom, Sir. Now with what velocity should an alpha particle travel towards the nucleus of a copper atom so as to arrive at a distance 10 power minus 13 meter from the nucleus of a copper atom? Now we will take alpha particle. Alpha particle is He2 plus. He2 plus ion is called alpha particle. Sir, He2 plus ion is having only nucleus, no electrons. In this nucleus, 2 protons present and 2 neutrons present. He2 plus ion is not having any electrons. Okay, it is called alpha particle. Okay. Now, copper atom. In the copper atom, we have to take the nucleus. Sir, this alpha particle is moving with a certain velocity. Okay.